Now, when we go to simplify a root of a number, sometimes we have to try dividing by a lot of possible factors. And we really want to make sure that we get the biggest possible factor for which we can actually take the root. How can we do that? Well, we have to go through and systematically divide until we know we've found all the factors. So here I'm trying to simplify the square root of 108. I know that 1 squared is a factor, but that's not interesting. I found out that 2 squared was a factor, and I might be tempted to stop there. But then I found that 3 squared was a factor. I found that 4 squared was not a factor, and neither was 5 squared. And again, I might have been tempted to stop. But if I keep going systematically, I find that 6 squared is a factor. 7 squared is not a factor. 8 squared is not a factor. And I've stopped here. Why did I stop here? That number is less than 2. Why does that matter? Well, it's because any remaining factors now are going to be less than 2, which means they're either going to be 1 or they're not going to be an integer at all. I don't care about factors that aren't integers. Factors of 1 aren't interesting either. And checking on the calculator, I see that the square root of 108 is not an integer. 108 is not a perfect square. So I know I'm not going to get to a point where 108 divided by some perfect square is 1. Once my quotient here is less than 2, I know I can stop. But here I had to divide by 8 different perfect squares. Once I've done that, I know that 108 is 36 times 3. So this is going to be the square root of 36 times 3. That is the square root of 36 times the square root of 3. And I also know from that same process that 36 is 6 squared. In other words, the square root of 36, that's just equal to 6. And then I'll leave my square root of 3 alone. So I found that the square root of 108 is equal to 6 times the square root of 3. And double checking on the calculator, the square root of 108 is about 10.39, and 6 times the square root of 3 is also about 10.39. Right, and again, looking at the calculator, I see that these are actually the same awful decimal. I really do get equal numbers. When I say that they're equal, I mean equal. So I had to go through that big list of perfect squares, divide 108 by everything. That's a long project of really repetitive arithmetic, time-consuming and error-prone. I want to have a computer do this for me. So I'm going to show you again how to do this on the TI-84. If you have a different calculator, check in with me. You can also do this in a variety of programs on a computer. This is very similar to the procedure that we used when we were trying to use the AC method. We're going to use our table function. So the first thing we're going to do is put our perfect Pth powers in one variable, and then the number whose root we want to simplify divided by a perfect Pth power in another. We'll go through the table and we'll find the largest perfect Pth power that's a factor of our number. So let's use this process to try to find the third root of 112. The first thing I'm going to do is press my y equals key, and this gives me my enter an equation screen. The index for my root is 3. So for my y1, I'm going to enter x to the third power. For my y2, well, I'm trying to simplify the root of 112. So I'm going to take 112 divided by x to the third power. X to the third power doesn't need to be in parentheses here because exponents happen before division automatically. And then I'm going to press second followed by graph to access the table screen. So 112 divided by 0 gives me an error. That's to be expected. 112 divided by 1 is 112. That's fine, but a factor of 1 isn't useful. 112 divided by 8 is 14. A factor of 8 is useful. 27 isn't a factor because I have 4.1. 64 isn't a factor, I have 1.75. And 1.75 is less than 2. So I'm going to stop there. So pasting the calculator screen into my notes. This is less than 2. So stop here. And we see that the row that's going to help us is where we find that 112 is 8 times 14. So if we're taking the third root of 112, we're taking the third root of 8 times the third root of 14. We can actually do third root to 8. And in fact, looking at the calculator, we see that the third root of 8 is 2. So we'll have 2 times the third root of 14. 14 is relatively big, so we might be worried that we missed something, but we used the calculator to go through this systematically, so we know that we didn't. And again, on the calculator, we can look at the third root of 112 is 4.8 and a bit, and 2 times the third root of 14 works out to exactly the same decimal. So those really are equal. They really represent the same number.